Hi, hello, welcome. Look, it's this show, and it has started. Hello, thanks for joining me. Look, it is. Oh man, I didn't update that little title. It's not that show. That show was last week. This is the Adaptive Joysticks. There we go. Fixed. Whee! Shoot that over there. Look. Yep, that's not how you spell sticks. Sticks. Let's move it over a little. There you are. That's how you know it's live. First of all, I want to say thanks for stopping by. We have people over in our chats. Hello, Randall Bone and Beata Grafov Del Hagen and Dave Odessa over in our YouTube chat. And then pretty much everyone else is in our Discord chat. So if you are somewhere else and you're wondering where the chat is at, check out Discord. It's at adafruit.it/Discord. That'll get you an instant invite to our server, and then you can look for the live broadcast chat channel. And it looks like 2 of my screen captures went wonky. So again, more behind the scenes while I go and fix this and turn that into the Discord window. Good. And then this one should be a Chrome capture. Fixing that now. All right. So thanks for sticking with me. I'm going to dangerously hit save. So what have we got going on today? I have a coupon code for you. I have a 1-minute wrap-up of the Product Pick of the Week show. I have a Parsec, CircuitPython Parsec. I've got a mystery cable. There's a mystery cable I want you to help me sleuth out. What is this thing? I have a Learn Guide recap, and then I have a new sort of quickie project. I've started showing a little bit this adaptive joysticks thing, and I'm going to continue with that and show you how that works with a TRRS trinky today, and then I'll write up a little page in that Learn Guide for you. So, with no further ado, here's a coupon code. Cooked. That's today's coupon code, Cooked. That will get you 10% off in the Adafruit store. Just head on over there, look for some neat stuff, throw it in your cart gently, and then when you're getting ready to check out in the coupon code slot, type in Cooked. That will take 10% off of your order, and that is good until midnight tonight, East Coast time. That works on physical goods. That does not work on software, gift certificates, or subscriptions, but for physical things that you can buy, you can use that coupon code and get yourself a nice savings. And this right here is some additional savings that you ought to know about. Let me resize that window a little bit. That looks better. And that is the free stuff. What are the other deals we have? Not only we have a coupon code, but if you buy stuff in excess of $99 or more, you'll get a free PCB coaster. That's it right there. If you spend $149 or more, you'll get the coaster and a KB2040 keyboard. Very cool board. If you spend $199 or more, you'll get the coaster, the keyboard, free UPS ground shipping in the continental United States. And if you spend $299 or more, you will get the coaster, the KB2040, the free UPS ground shipping in the continental United States, and a free Circuit Playground Express. If you're wondering what to get, hey, look at this neat stuff. We still have these in stock, these funky little Seed Studio round touchscreen displays for Xiao. This looks very neat. I haven't gotten one yet, but I may. That's pretty snazzy. You just pop a Cutie Pie or a Seed Xiao on the back there, and you've got a touch screen, a little circular touch screen to do some neat projects with. That is just one example of a thing that you can get 10% off in the Adafruit store by using the coupon code COOKED. That is your coupon code for the day. Next up, I have a show on Tuesdays. Many of you may be familiar with it. It's called JP's Product Pick of the Week. On that show, I pick a product, I show it to you, do some demos, give you a massive discount on it. And this is a little 1-minute wrap-up of this week's product pick, which was this, speaking of Trinkies, this adorable Pixel Trinky. This is the product pick of the week this week. It is the Pixel Trinky. This plugs right into USB. It's an M0 processor, and it has terminal blocks for either NeoPixels or dot stars. I have it connected to one of our little LED rings. I've got a bit of plastic for diffusing. I've coated it in fast LED, and now I'm just going to plug it into a battery pack. And you can see, if I shield that from some of the bright light there, or just reflect it off of something like a human face, you can see there I've got a cool little Pride Month logo color effect happening there. I've also got that in a little bit of heat shrink tubing that you can see. Maybe there's some clear heat shrink to give it some protection. And then you can put it back on this. I left it open so that you could see it a little better. This week it is the Pixel Trinky. Just hitting all kinds of buttons here. Yes, it was. That was the product pick. Next up. Oh, by the way, let me make one point about that. The other demo I did during the show, you can go back and watch the whole live stream if you want. If you go to YouTube, Adafruit channel, videos live, you can check out all the old shows. This was the other example I showed, which was Pixel Trinky, a 90 NeoPixel side lit strip here. And I had this running the code that Liz created a UF2 for, so it's easy to download, but there is code and Arduino code, if you want to go a little deeper into it, that allows this to work with the Windows dynamic lighting. I demoed it on that laptop. It is super, super cool. It allows you to do things like, if there are applications, games that can control the color of your various devices, like mice, keyboards, this thing, light bulbs, I don't know. You can use this. However, I noticed last night that after I finished all that, the backlighting on my keyboard wasn't working, and I was trying to play some Tarkov, some Escape from Tarkov, in the dark, and I needed some backlighting, and it wasn't working. And so, turns out the solution was this is a Dell laptop. They acquired Alienware a long time ago, and they have Alienware Control Center, even though it doesn't look like an Alienware laptop. By running the Alienware Control Center, that fixed or restarted the backlighting, the keyboard backlighting. So there's sort of conflicting. There's the Windows dynamic lighting thing, but then there's this application. So I imagine there's some things to work out there with who's actually controlling the LED lights. But I got it working again, and then got killed really quickly in Tarkov because it's difficult. So that's my little spiel about the dynamic lighting. It's pretty cool, but it's also worth knowing there may be things that are fighting for control over your different RGB lighting effects. Next up, hey, this is neat, I think. I've got a CircuitPython Parsec for you.
CircuitPython Parsec.
For the CircuitPython Parsec today, I wanted to show you how you can use the built-in help function in CircuitPython for your microcontroller board. So what you'll see here over in my, first of all, downshooter, I've got a Feather RP2040 plugged in here. Since I am halting the running program with Control-C, it lights up that NeoPixel, super bright white, so I've just covered it with a little twist tie kind of thing there. That's what that is. If you're wondering what the mysterious orange umbilicus is, that's just to protect our eyes and the camera. If you look over in my code window here, you'll see that I've just commented out a few example things that I want to show. So first of all, if I restart this board, you'll see it just starts up and says help with help, and that's a little print statement. So this is the code.py that's running. So what I'm going to do is hit Control-C, and that is going to give me a command prompt that I can talk directly to the board. So here's the first one. If I just simply type in help with parentheses as a function, it will say welcome to CircuitPython and the version you're running. And then it says visit circuitpython.org for more information to list built-in modules. Here's a hint. Type help quote modules. So let's do that. If I say help modules and hit enter, this will show me all of the built-in modules on this particular board's CircuitPython. So here you can see we've got things like analog I/O, audio mixer, right here. We have digital I/O, JSON, math, RGB matrix. So these are all libraries that are built into this cut of CircuitPython for this particular board. If I want more help, I can ask for help on one of these modules. So I'm going to say help, and then in quotes, the name of one of these modules. Let's do math. And this now tells me what are the different functions inside of the math module, which is really helpful because you may be wondering, hey, do I have a cosine function, or is that part of something else? Is that in math? So this is one way to just very quickly check out some of the functions that are available in a given library. Now let's try another one. I'm going to do help with, actually I'm going to, sorry, let me back that up. I did that wrong. What I'm going to do now is I'm going to import a module. So let's import math. Then I'll say help with that module that I just imported. Okay, that's the same thing. All right, so let's try this one. I'm going to do import board. And now let's do help with board. Okay, so now I get a list of all of the different pins that we have broken out on the board, as well as not only these sort of nice names on the left, but we also have the names of those pins as they're going to be called inside of CircuitPython. So this is helpful. Sometimes the silk screen won't actually be the real name. So if you're wondering, what do I actually have to ask for MOSI? On the board, it just says MO. Okay, here it is, board.MOSI. Let me try this other example one more time, because I now think I know what I did wrong. So I'm going to import math, pretend we're doing this from scratch, import math, and then I'll do help math. Not in quotes. Okay, now it tells me all of the functions that are available in this module, including things like square roots, cosine, atan, floor, and on and on. So these are some ways that you can get help on your board and on the modules for your board right inside of CircuitPython using the help function. And that is your CircuitPython Parsec. So in the chat, by the way, someone said, whoops, wrong window. Go back to this. Where's my chat? There you are. DigiDevin3 said, interesting, honestly didn't know you could do that. I didn't know that either until yesterday. And I think some people have mentioned it before in the chat during the CircuitPython Parsec, particularly I think when I do dir board to find out the pins, which is partly why I was fumbling around with this, because I just haven't used it much. But this is what I usually do, dir board, after it's been imported. So this gives me the same list, it's just formatted differently, and it doesn't give me both the nice names and those board names. So there's dir board, here is help board. So it's just a different formatting, and you get the two different names, the sort of nice names and then those board names. I think these line up in most cases. You can see some of these are telling you about functions on the board rather than just pins. So there you go. If anyone has insights about this, please let me know, because I find it interesting. There's not a lot of info about the help module. But yeah, I really like this thing, just being able to say help with modules, or libraries, as Devin said. There you go. You don't have to go to a web page. You can just right here find out, hey, I've got this board. Does this thing have the audio I/O? Does it have synth I/O? Yeah, okay. So some boards will or will not have different modules available or libraries, and so sometimes you'll go to the web to check the matrix out to see which ones you can use. This is kind of another neat way. Question, can you drill down into help? So for example, help math.sign. Let's find out. Help math.sign. Module has no attribute sign. Interesting. Help math. Sin, S-I-N, sorry. So help math sin. Doesn't give you a lot of help. It tells you it's an object and it's of type function. So I don't think that'll be all that useful. But if anyone knows other ways of using the help function, let me know. DG says, I feel like that should have been in the CircuitPython Essentials Learn Guide. Would have loved to have learned that one a long time ago. Me too. Okay, maybe we'll add that. That seems like a good one. I'll make a note. Add help note. All right. So let's see. Next up, the mystery cable. I'm going to leave this view behind and head to here. Get this out of the way. I can unplug this now. And first of all, looks like your average everyday USB cable. Goes from USB-A to USB micro B. Zoom out just a little bit here. And it has this identifying mark on it. Looks like a company name or a logo name, PLT. It says that on both ends, PLT. And then you'll notice this weirdness here. So there's a kind of a cap holder. You'll see these sometimes when you have adapter ends where you can switch between different types of USB ends. But lo and behold, when you pull on the USB cable, appropriately enough, you get a TRRS 3.5 millimeter cable. What the heck's going on here? What device would go from, essentially, I would think this would work as a USB cable where you have replaced your USB-A port on the host side with a TRRS jack, and then this would plug into whatever. I don't know what this used to, it looks like something got snipped off here. This came, I think, from some piece of consumer electronics in our house. One of my kids handed it to me and said, here, we're cleaning out a drawer, and I am baffled. What uses this? I haven't Googled it at all. So, and I love this because people have mentioned on the chat as we've been doing some of these TRRS breakout things and the TRRS trinky, hey, can you use that it's 4-wire, and that's what USB sort of 2.0 and even 3.0 cables are. I don't know how shielded it is. I don't know if it would work very well for data or not. Can you charge over it? Who knows? But certainly weird, right? What is that? What's that for? It makes me kind of want to get adapters so I can just run weird versions of not USB through USB cables. I don't know. It seems like a bad idea, but it might be worth trying. So what is this? Why does this exist? I'd love to know. There it is. They don't want you to lose this. That's thoughtful. Who's PLT? Someone Google this thing. What's it for? We don't know. Why? Why would you do that? Is that standard in any device type? What's happening? Someone tell me. All right. That's the mystery cable. I will, if anyone's got info about it during the show, pipe up. If we get comments in the YouTube, I'll check for those and try to follow up. I might do my own research on that bizarre thing. I haven't even tested it. I don't know if it works as a normal USB. You'd think it would, but wild. Beatagraf of Delhagen says, I'm guessing it's from some not so well-known PDA type device or a feature phone. Oh, interesting. Could be. Yeah, maybe something small enough that it needs to be a host but doesn't want to have a full USB-A rectangular plug in it. That's pretty small. It's a nice way to shrink things down for sure. All right. So next up, let's polish off that sparkling water, and I wanted to do a little Learn Guide recap. So let me head over to this view right here. And here it is. This is the Learn Guide for my Lego drum sequencer, the optical sensor drum track sequencer, as I called it here. So we've got a little demo video at the top here you can check out, a little explanation of it, some parts, so you can go and get the right things if you're looking to build one of these yourself. I don't list Lego on here on this front page, but I do have that during the build section. I'll show you in a second. So first thing is build the circuit, and that's the circuit diagram I did in Fritzing there. So you can see we have a feather tripler, which we don't have one of those in Fritzing, so I just put a doubler, and you can imagine that this motor shield is on the top one. But I put this here so that I could show particularly on the doublers and triplers, we have this row that is all the 3V3, 3-volt line, and then we have another column, I should say, another column that is all ground. So that's really convenient if you have, in this case, 4 different sensors that all have a ground and power line, and rather than sort of wrapping them together and just soldering one pin on, I soldered them into some headers on the board here. So that is how the sensors get power and ground, and then, oops, this is the pins that they are running to for their signal, so 12, 10, 9, and 6. And then the motor shield is also on the feather wing, so that's all connected. And then we have the color-coded plug for our stepper motor. It's not clear sometimes what gets plugged into what on these steppers. So if you follow this color coding for the steppers that we sell, that I put in the parts link, that'll work just fine. And then I kind of had to gin up this part here because we use those. Where did I put it? I've moved it over here, but I used the little inline DC power adapter, not 2 separate pieces like this. So that's the circuit. Then I've got a little prep section on soldering up the parts. And there you can see this is, I don't know if I've shown this clearly before, but this is the clearest picture I have of putting in 2 rows. We happen to have those color-coded header pins, the sockets rather, header sockets, which are useful in this case just for power and ground. I think it's always a chance that I'll mix them up and plug them in the wrong way. So I used the red socket there to show which one is power on those. The sensors there just getting glued with a little U-glue dot to a Lego tile so that we can build the little bracket for that. And then the good fortune of the hole spacing for the mounting screws on the stepper motor happened to align almost perfectly with the hole spacing of Technic brick pin holes on the sides there. And then there's a picture of the final all put together. And then for this build the sequencer section, I did one of these build movies inside of Lego Studio or Stud.io, Bricklink Stud.io I should say, which these don't try to accurately put the parts in. They all kind of go through each other to get to where they need to go. But that may be helpful for some people just to scrub through to see where things go if you're trying to build this. The other thing is if you head to, there's a link here that says to build the Lego portion of the sequencer, you can use the instructions found here. So since I built this in Stud.io, the Lego CAD, you can view an instruction, sort of automatically generated instruction that you can go through, click through and look at the build. Or you can click on this View 3D Model if you need to get close to stuff. This is great. This one just works in the browser. You don't need to download the CAD software, but it makes a impressively lightweight version of the model. Or this is a really robust viewer, I'm not sure, maybe a combination of both, that you can use to see how things are assembled. And if you do click on either download the Stud.io or Studio file and open it in Studio, you can mess with it, upload your own CSV, comma separated value list, to purchase them from the cheapest sellers you can find on Bricklink, or click Easy Buy. It'll throw it all in a cart for you there. I think it was roughly $60 or something for these parts was the best price I found for throwing it all together. And there it is in the real world put together, and then attaching the little sensors there. We can use those trimmer pots to adjust the distance away that it will bounce that reflection. Basically how high power is, how much current is going through the infrared emitter so that it can go a little further and bounce back with more strength. So you can tune that to get the right sensitivity on the optical sensors. There's the sensor wiring, there are the triggers doing their thing, there's that power switch. And then in this little, DJ73 says, it looks like tank tracks with Lego heads for traction. It totally does. I have this extra sort of bandolier of them. These are definitely tank treads. Like that's what these are meant for construction vehicles and like fantasy sci-fi vehicles in the Lego world. These are tank treads, and they're definitely using heads for traction there. Someone was asking me, actually Jepler was asking me about the origins of this project, and when I was thinking about building it, I was going through some bulk Lego and came across some of these wide treads, and I had never used these pieces before, and I was like, ooh, that could actually work as a little sequencer conveyor belt, basically. So, in this Use the Sequencer section, I have a couple of suggestions on some software synthesizers you can use and some drum patterns you can get from some venerable drum machine patterns books and posters. And then this was actually Todd Kurtz's suggestion. I was looking to find if there was a web browser-based web MIDI drum sample player or drum synth player that accepts MIDI. Really didn't find much anything. You can find a few pretty good drum machines in a browser, but they're not looking for MIDI to come in. You can find a lot of good synths in the browser that accept MIDI. This is usually Chrome, but couldn't find one that was gonna work with the drum sequencer. So next best thing I think is the VCV rack, which is free, open source. It's pretty quick to download and install. And I've got a sample patch you can download here that just uses these, like 6 modules. So we have a MIDI to gate. So the 4 MIDI notes that the drum sequencer plays are a C, C sharp, D, and D sharp in the 3rd octave. Each of those, when they come in, will trigger one of these drum sample players, and then those go into a little mixer and out to audio. So that would be one way to just get up and running really quickly. It's free, it's open source, it requires just a little bit of downloading. I wish I could have made it so that it didn't use any additional modules than the ones that download with the software. These gray ones here are the VCV labeled ones, are just installed by default. Pico Drummer or Pico Drums from Erica Synths, that's free also, but you will have to do one additional step to download those. And bug me on the Discord if you run into any problems using that. So that's an example of a drum machine you can play using your Lego drum sequencer. All right, good. We good? Okay. Okay, more wire hypotheses, also from Biata. Perhaps a dual function USB UART port. I've seen even stranger things. Also, Retired Wizard, I think I remember a UPS having a cable similar to that one. And there's a little link. Oh, DJ Devon 3, Plantronics. You could be onto something. I think we had some Plantronics brand wireless headsets. Could it be? That's a good guess right there. A good insight, I should say. Could be Plantronics. I don't think we have that headset anymore. Why would they do that? Why would they put that on there? What was their big plan? I would expect it to be the other way around, maybe. Like you could still go USB host into your computer and use like a USB audio if it had an audio interface, and then TRRS into the headset. No, I think you're right. I think Plantronics. That makes sense. Okay, we're getting closer to the crux of it. Thank you. Okay, so next up, I have this adaptive joysticks thing, project, situation. So let's head over to the workbench and I'll talk about what I've got here, what's going on. And I'm just going to open up Discord. Keep an eye on the chat. So, what's all this? What's happening? I'm going to get this set up to demonstrate the little gamepad tester. So, the context here is adaptive controllers for games. And this is the Xbox adaptive controller from Microsoft. You've seen me use it before. One feature I really like is it has a few different standard mounting threads on there. This is a tripod mounting thread in the middle. And so you can place it where you want. You can connect this to different mounts on if you have a wheelchair or something where you need things mounted in a particular place. They make that pretty easy to do with those standard mounting screws. I just have it on a little tripod here, and the adaptive controller is both wired and wireless Bluetooth that functions really well with an Xbox or with a Windows machine. And it has some basic controls that you can use right on the surface of it. So we have a D-pad, and if you look at my little controller tester, this actually, I'll unplug that. That was just charging the battery in it. If I press my directional pad here, you'll see little D-pads lighting up on the screen, so you can tell it's plugged in. Here it says HID compliant game controller, standard gamepad. If I press A and B, those show up up here like A and B typically do. We have a select and a start button, and that's about it. This button here just toggles between saved profiles, so you won't see anything light up there. And this button sometimes, well, it's lighting up here as B16. That's what's getting toggled here. This is a home button, will often take you back to like the main menu, kind of back out of a game into the main menu. And then everything else with this is 3.5mm jacks, which is a standard in adaptive controller community for any kinds of buttons and SIP-puff controllers and you name it. They're going to use this type of control. This one happens to be a stereo cable, but it will work in these in mono applications. Sorry for the confusion there. But for example, if I plug this into X, so this is the X button. Now you'll see there's a button lighting up on the screen there, and that's a foot pedal. So we can use this one standard of the 3.5mm mono cable for most of these. Some of them will use stereo for some analog things. And then I worked on a guide for this a couple years ago and covered a lot of those scenarios, but the one thing I didn't touch was these USB ports on the side. These are expecting a USB joystick, such as a flight stick. Modern, not an old parallel port one, which I kind of have in excess. I don't have any actual USB joysticks that are analog. And what these are here for is most game pads. Do I even have? I don't think I have a normal game pad laying around in here right now. But most modern game pads have two thumbsticks. So those are analog joysticks. They look a lot like this. Little analog joysticks, and a lot of modern games expect you to move with the left one and look, head turn camera kind of stuff with the right one. And so rather than attempt to add those to this, they give you these USB ports to plug in USB joysticks, which you can then hack and modify to work for your particular adaptive needs. And so with the introduction of this little guy right here, which is the TRRS Trinky, this is an M0 microcontroller. It has a USB-A plug on it. It plugs right into the USB port there, and then it has 4 pins that you can use with a 4-conductor cable, TRRS cable. You know, I'm going to zoom in a little bit for some of this stuff. So that we can get things like a voltage, a ground, and 2 analog potentiometer reads, which is what this type of joystick is made up of, or this type of joystick. In fact, you can see on this one the 2 potentiometers. I'm sharing ground, I'm sharing voltage, and then the wiper of those goes out to one of the 2 ring conductors here. How this is mapped can vary depending on your needs, but since we're going into the Trinky here, I can simply say, okay, I'm going to tell the tip to be a ground and the sleeve to be a voltage, or vice versa, and I'm going to read the signal on the middle 2, and then in code in CircuitPython I can say, let's send those signals out as USB joystick commands, which can be understood by the Xbox adaptive controller as a sort of standard. So we'll keep this zoomed in, and let me focus on that screen a little better. So what I'm going to do is take my adaptive controller, plug in my Trinky on the side there, like that. And now this little thumbstick and thumbstick breakout has control over the thumbstick in game. So whatever game you're playing, that's going to control maybe head look kind of stuff. I can just take that out and plug that in on the other side, and now we're going to be able to move the left thumbstick there. It took it a moment to enumerate the USB gamepad. But you can see here we have a nice little readout of your center position, the values you're getting on these two axes, and then we have a nice little visualizer there. This, by the way, is called hardwaretester.com/gamepad. If you look up controller tester, it pretty much always shows up in search results as #1. And then I've taken this and attached it to one of our little swirly gig, whatever we call these swirly grids, so you could maybe tap that for a threaded connection, mount it to whatever you need. Another thing is this is a somewhat standard little cap here, and if you look around, there's a lot of people who've made 3D printable models of different types of caps. So this one is pretty standard thumb pad size, but you could make it much bigger so that it's easier to control if you have less dexterity. You could make this something you can use with a different body part, use your chin on an elbow. It doesn't have to be just this little thumbstick kind of thing. Another interesting thing is that if I go ahead and unplug the TRRS cable that this thumbstick is on and instead take, where did you go? A different joystick here. I'm going to zoom out a bit for this. So you can see I've taken one of our little, we call them mini joysticks, the one with the two obvious potentiometers on there. And I'll set this over here to the side. Hopefully you can still see that. This one I just have in a TRRS breakout right here. I'm going to plug that into the trinky, or you could leave the trinky plugged in and plug in, swap out different controllers, and that's the nice thing of having this standard. We're not trying to figure out some screw terminals on the side of this thing or soldering directly to it. Instead, we just plug this in, and after a moment, we can use that joystick there. I'm going to take it out of its holder. And this one you can, I modified this one, you can unscrew the base of it and take out the springs. So you can see this one does not return to center. Get the lighting a little better on there. This one stays where you put it, so you can see for some applications you may not want to be fighting the spring return, or you may want to just nudge this in a direction and you're walking that way and you don't have to keep constant pressure on this to go where you're going. So that's kind of nice for different applications to be able to modify that. I can't remember if this one is, it did it a long time ago. I can't remember. It may have been two springs that I unhooked and lost. But you can, I think it's a reversible hack. You can put the springs back on there. I believe there are some joysticks you'll run into that have a physical latch to engage or disengage the springs. But that's another neat use. And again, you could adapt this stem here to be much longer, to be wider, to be able to connect to other devices. So that's another, I think, nice thing about this whole setup is that you can use it with different controllers, different input controllers, but just the one trinky there is doing the heavy lifting of the USB stuff. Now on the USB side, you can do much more than this is doing, of course. You can have it filtering for you. It can take, you could do things like, even though I'm on a spring return joystick, I've pressed and released, you can say, you know what, I want it to ignore that. I want it to always stay at the max, so you could treat it like a virtual springless joystick. So there's a lot that you can do in code. And what I wanted to do is actually look at that code now. So I'll go ahead and unplug this from here. And I'll plug back in this nice one right here. And let's take a look at what this is running on the computer. Okay, so I'm gonna just close this previous code. Will not save that. And so you can see here, there's the TRS trinky. I've got it plugged into the joystick. If you don't, you're going to get floating analog reads, so the voltages are going to kind of wiggle around and you're getting a lot of readouts. So I'm keeping the joystick plugged in. It's easier during development, but you don't have to have it there. It'll still work. And I'm just plugging this into a little USB-A extension cable. Set that so you can see it. And let me open up, first of all, the code.py on here. So this is both this code that you see here in its original form and my slight modification are going to be in the TRS Trinky Learn Guide. And you can see here I'm crediting Bill Binko, who wrote this. I just did very small modifications for analog. What Bill did was Bill wrote a way to use buttons as an analog joystick, which is probably the most exciting use for this TRS Trinky in the adaptive controller, because there really wasn't a way to do that. You really needed to get code involved. This joystick could plug into some ports on the back of that that are made for reading analog, so it's not as crucial unless you start adding filtering and doing other software tricks. But Bill's code uses digital buttons to act like an analog joystick. So the things he had set up here, I'll actually open the bootpy and these two libraries. So there's a Xbox Adaptive Controller settings.py allows you to change the smoothing factor you're using, invert the different axes, so that's a nice little convenience file there. The library itself, and a lot of this is about getting it to show up as the right kind of gamepad, HID gamepad device to the controller that it's happy with, so that the Xbox Adaptive Controller is happy with it. The bootpy does some setting up of USB MIDI and HID. I don't know why it's importing MIDI actually. Oh, to disable it, that's why, yeah. On some of these boards, I think you'll just run out of memory if you're importing USB HID. I think you have to disable MIDI explicitly to get it to work, if I remember correctly. You can also do things like disable its storage, so it won't show up as a CircuitPy drive. So you can do some neat stuff in the boot.py. But then here there's the descriptor, and this is the specifics of what makes it look like a joystick to the Xbox Adaptive Controller. And hopefully Bill will be writing this up with some explanation of how he arrived at this, where the specifics come in. And then the code.py. So main things that are going on here, we're of course importing that Xbox Adaptive Controller gamepad library. And then I've got analog I/O in here. I'm not using keypad, which I believe Bill had in his because he was reading physical buttons. And the only reason I'm importing digital I/O is so that I can make the tip look like I think ground, and the sleeve look like voltage. I set one high and what low, might be the other way around. And then the two middle ones, the two ring 1 and ring 2, I use as analog inputs. There's a nice little rolling average function that Bill has here that lets you take out some of the chatter and noise of the analog joystick read. Here I'm setting my sleeve as the ground, okay, and then the tip as a voltage, and that's just simply by making them digital outputs and setting them either low or high. And then these are the two analog ins that I'm reading on ring 1 and ring 2, and that is the Trinky. It's nice, it doesn't have us look for what pin is the ring. Is it pin 3 and the next one is pin 4? You can just call them by name, so ring 1, ring 2. In CircuitPython, they have nice convenient names. If I remember correctly in Arduino, you do need to check the pin out and get the pin names. I don't think it's on the silk screen anywhere. Then I'm using a remap here to turn the 16-bit analog voltage reads that CircuitPython uses internally, even though it's not a 16-bit DAC, it does the math in 16-bit numbers. So it'll spit out 0 to 65,000, whatever. And I'm just going to remap those to 0 to 255, which is the range that we're expecting to spit out to the USB gamepad. I'm actually going to have to check because I've got average smoothing here of 3, and I think it's also specified here, so I'm not sure if I need it in both places. And then we do the gamepad reset, and then the main loop here, I'm getting my remapped ranges of the two ring 1 and ring 2 that I'm reading on there. Those are the two joystick potentiometers. And I did a little bit of, I can show you here, I'm going to show you what kind of numbers I'm getting raw number wise. So I get a middle point of about 33,000. You can see if I go far left, it's about 560. Or far all the way down, about 540, 560. If I go all the way to the right, I get about 65,050. And if I go all the way up, I get about 65,020. So I took those numbers and put them in as my remap ranges. I flipped them here because I actually forgot I could use this to flip them. I was getting an inverted vertical. So I could make that a little more sensible by using this as 540 to 6500 and then changing the vertical inversion right here. So we take those values and read them, then we calculate the rolling average, add the smoothing, and then if those have changed, then we're going to send that gamepad move joysticks and then the two values. You see that message sends both at once, which is nice, so it reduces lag. And then I was just during testing printing out what those values are. So center is about 128-ish, right 255, left 0, down 255, up 0. And then there's a little bit of a pause there to avoid overwhelming the Xbox adaptive controller, and I'm guessing Bill found that out from experience, that it would be good to reduce the amount of messages being sent from the trinky over to the controller. So if you take a look, though, in practice, let me go back over here. I was testing this yesterday with a game, and that game is Overcooked. So I think it uses the right stick for movement. I'll switch over to the game. Uh-oh, I don't want to restart the game here. Oh no, we're going to have to... Oh wait, is it going to send us... Okay, this is the time travel part. That's okay. We don't have to go through too much. So, if this works, yeah. So there's the little movement there. I've gotten to the door, I have to hit A. Okay, so the nice thing, if you don't know Overcooked, it's a very high pace, high stress restaurant cooking and serving simulation game, arcade style. Hugely stressful, but the menus are very relaxing. So this is actually kind of a nice place to go and just test out this joystick control without having to worry about any timers or anything like that. And you can see here, if I take that joystick and unplug it and plug in this other one. So this is what I was talking about being able to set it where you're going and it doesn't spring back, so you can keep it running in a direction forever, which can be helpful. So I'll unplug this one though, and I'll go back to the other thumbstick. That one's easier for me to use. And I can't remember. I think I need one extra switch. We'll see when it yells at me. But let's try to... Is there a single star? Yeah, let's go to this one right here. Hit A. So, how to make basic soup. Oh, maybe this is a tutorial one that won't be super fast. Let's see. So I'm going to run over here and pick up order an onion. I'm going to put it in the pot. No, I'm not. I'm going to chop it. Is that what I'm going to do? I'm going to chop it. Oh. So I think chop is Y. It's X. So I don't have X on here, so I will take my foot controller and plug that in. So now I can keep that held down, and it's just going to chop. So I can put that down on the ground there to chop, chop, chop. Okay, we're done. Now I'm going to put that in the pot. And do it again. So I won't make you watch. Yeah, this is nice though. This is a tutorial one, so it's not stressing me out about the time. Chop, chop, chop. If I added another button that gave me Y, then I can switch over to the other little mini chef there, I think, and go and, let's say, save that from overheating. So I got to get all the onions in there before I cook it. So that's what overcooked is. That is why the coupon code was cooked, by the way. But you can see there, that works pretty well. I can, again, swap this out. And as you can imagine, anything with a couple of analogs, voltage divider-y kind of sensors, such as potentiometers, slide potentiometers, touch soft pots, so long as you can come up with a way to plug them into a little adapter and into the TRS Trinky, you can use that as an analog joystick. So I think I'll end that there. Escape right there. And yeah, now I want soup. Who doesn't want some French onion soup? That would be delicious. Paul Cutler says, my family likes to play Overcooked. It does get stressful. It's a great family yelling at each other kind of game. One thing I was thinking of doing was, I can get this out of here. You may remember I had gotten this wild golf swing controller. Put that back enough to show it. So this thing here, as you'll remember, these are two analog joysticks, and then they also happen to have a third potentiometer that, with a little reel mechanism, tracks that Z distance. So you could potentially have just those two Z's as your up, down, left, right, or use these from a pretty great distance as a very large motion. If large motions are easier for someone, a very large motion-based controller, those could be plugged right into the TRS Trinky and used as analog. So I may do a little bonus build of that, but the primary goal here is just to put some example code into the TRS guide so that you can see how to set up your own. Oh, hey, Bill is here. Hey, Bill. Great to see this project. Yeah, so the code is up on the GitHub. I'll show that right now. Let's go to GitHub, Adafruit. I believe it's in the TRS Trinky guide, actually. So let me find that. So here you can see. So Adafruit Learning System Guides, TRRS Trinky demos. We have an AT demo, analog mouse demo that Liz did, chording joystick, and 2-switch keyboard and AT demo. So this chording joystick, I think, was where I got all my code from. Yeah, that's it right there. Which, if you look at what Bill did here, was make it use buttons to sort of simulate the analog joystick, which is very cool and something you kind of just couldn't do with the Xbox Adaptive Controller on its own. If you're going to move the analog thumbsticks, it is designed to have you plug an analog thing into it. So this is I think the exciting part about the TRS Trinky is in code, Bill was able to write code that takes digital buttons and makes them present themselves as analog, which is really cool. Test check. All right, we're back with audio. Thank you for people telling me. Let me know if there was anything you think I said that you wanted to hear about, but this is, yeah, batteries died on the receiver pack. This is the TRS Trinky guide. You can see here, actually, this red one is just not published yet, so that's where the chording switches for the code that Bill wrote there that I was showing. DJ Devon 3 says, at least it didn't happen during the Parsec again. Yay. Phew. Yeah, you know, I wonder, yeah, Todd said on the side, it's a clicky noise when the audio died, like switched off or unplugged. Yeah, that's when the batteries die on my receiver pack. I may try to see if I can adapt that with like a bigger LiPo that runs it. It's just 2 AA's. I don't think I want to plug my receiver into a wall adapter because I'm going to risk a whole bunch of noise, a whole bunch of hum. So, oh, Bill says, sorry about that, I'll get that posted. No, I don't mean to pressure you, that's fine. But that's where you'll go to learn more, but in the meantime, you can just head to this repo if you're dying to see the code, that's where it's at. All right. I think that's gonna do it. Is that everything we had? It's nearly everything we had. I did want to mention again, Cooked is your coupon code of the day. So if you want to go to the Adafruit store, buy some stuff, get 10% off, that's how you're going to do it. And I think with that, I will bid you adieu and show you a picture of an otter. For Adafruit Industry, I'm John Park. This has been John Park's Workshop. Bye-bye.